like this. Now, because of that resonance stabilization in this case, this is one of the good leaving groups. So leaving group with base, it is not just nucleophile, it is basic in character because it is a conjugate of weak acid, tertiary butyl alcohol. Due to that, and temperature is also supporting. Now we have the possibility of two types of eliminations, unimolecular and bimolecular elimination. Unimolecular elimination is completely dominated by bimolecular in this case. Reason because of the bulky base and also very good leaving group. This is stronger bases. Whenever the strength of base is increasing, bimolecular elimination is favored. And also you can see in this case this is alpha carbon of the leaving group, beta carbon here. There is possibility of gaining the proton from any one of these two beta carbon here and here. But because of the size of this base, it predominantly proceeds towards carbon with less steric crowd or steric hindrance. So when you take proton from this, where it proceeds to a transition state. Transition state is, see here, this is the carbon with leaving group and adjacent here is hydrogen. Now the base is added towards hydrogen and here there is partial double bond character and the leaving group is, it is releasing from leaving group started releasing. So here this is not double bond, it is just partial bond. Now you can see in this case here base is adding at the time of leaving group is releasing. Due to that transition state, now the rate of reaction depends on both the concentration of substrate, this is the substrate, along with the substrate, base also alters the rate of reaction. That means it is bimolecular, so order of reaction here is second order. And the product obtained in this case is with the elimination, here the double bond is formed. So let me proceed for what is the first intermediate, that is first step of the product obtained. The first product obtained in this case so CH3, CH3, next CH double bond, CH2. Like this. Ozonolysis. Here there should be O3. Ozonolysis. O3H2O2. So we know ozonolysis that break the bond here because a ozonide is formed intermediate which is further catalyzed the hydrolysis by presence of H2O or H2O2. So here H2O2 is given. H2O2 is very comfortable reagent to avoid the confusion. Why? Because here once if it is given as H2O, then there might be some confusion. What happened? Here if there is aldehyde formed, whether that aldehyde will further oxidized or not, because H2O2 concentration from H2O is less. But here he gave directly it is H2O2. That indicates it is oxidative ozonolysis. Very clear, it is oxidative ozonolysis. The aldehyde whichever is formed along with formaldehyde another. These will further oxidized because H2O2 can oxidize aldehydes easily. Oxidative ozonolysis which leads to formation of formic acid and also 2-methyl propionic acid. So these reagents, these are the products in case of third option. You can see comfortably, very simple question. To avoid confusion, in the question they gave good leaving group means bulky leaving group. Whenever bulky leaving group is there, generally the reaction will favor half means elimination. And also by presence of bulky base, half means elimination is favored. So these two makes here the alkene at this point clearly. Let me go for the next question. That is the fourth question, which can show geometrical isomerism. 4-methyl pent 1-ene when the terminal position has unsaturation. Here we have both these atoms are same hydrogen. So in this case geometrical isomerism is not possible. But in second you can see here there is hydrogen, here also hydrogen. Means different groups present to the unsaturation on either side. So this shows geometrical isomerism. Here also we have double bond, and that double bond is again supported on one side with 2 hydrogens. If similar groups or atoms bonded on unsaturation, then it doesn't show us geometrical. Same in this case also. So 1, 3, 4 doesn't exhibit geometrical isomerism, but 2 can show us geometrical isomerism. Easy question to pick and very comfortably you can answer this. Let me go for next question, fifth question. The statement 1. High density polythene HDP is formed when addition polymerization of ethene takes place in a hydrocarbon solvent in presence of catalyst, Ziegler-Natta catalyst. So here you can identify one second, let me go for the previous question. This question was scrolled. So here, just see in this case, high density polythene is formed when addition polymerization of ethene takes place in a hydrocarbon solvent in presence of a catalyst, Ziegler-Natta catalyst. So Ziegler-Natta catalyst, it mainly favors the formation of high density polythene. Polythene, ethene, when proceed for polymerization in these conditions. Here we get high density polythene. High density polythene, this is with a linear. Why it is the density more? Because the molecules of polymer, they are compact, comes very closure. How they can comes very closure is if the chain is like this one, this is like a linear chain, then they comes very closure. If there are any branches, say for example this, like this, if there are any branches, now another molecule, it cannot comes very closure. That leads to low density polythene. But here in presence of Ziegler-Natta catalyst we get HDP. This statement is directly taken from textbook, NCERT textbook. We have this in polymers, direct statement. Statement 2. High density polythene consists of linear molecules and has high density due to close packed, and it is used for manufacturing buckets, dustbins and bottles. That is correct, because HDP, the higher density is due to, I already told you, this is the linear. So these two statements are correct, and it is the correct explanation. The high density is because of that close packed structure. This is, I said already, this is there in NCERT. We can see the second year NCERT textbook. In that, in part 2 in polymers, we have this exactly. Try to go through that once. because even for the advanced examination also, NCERT textbook will help you, and you don't skip the NCERT textbook, try to go through points. Let me proceed for the next one. See, in this case, the sixth question. In sixth question, if concentration of fluoride ion is up to 1 ppm, then which of the following options may be correct? Good for teeth, no doubt, because less than 1 ppm it causes cavities in tooth, and more than 2 ppm this leads to fluorosis, that is, it causes the softening of bones and also yellowing of tooth. Harmful for tooth and cause brown mottling of tooth. This is with high concentration, means more than 2 ppm. Harmful for bones and tooth, not correct. Harmful for the growth of children, it is not correct. This is correct, it is there in your NCERT in environmental chemistry, and also it is there in the introduction part of the colligator properties chapter. Also in introduction they specified the words. You can go through NCERT textbook. So it is directly the question selected from textbook. Let me go for the next one. Question number 7. See, in case of question number 7, which of the following lanthanides element do not